So hi everyone, starting at 7:05. Today we'll be going through Docker. The reason why Docker is important is because if you're becoming a full stack engineer, it's not technically part of your role. Back two years ago, companies would have a full stack team, a front end team, a back end team, a DevOps team. Today it's very highly convoluted who is what. And for that reason, I feel it's good, probably bare minimum expectations for a full stack engineer to know about Docker. So that's what we'll be covering today. The other benefit of using Docker is if you are using Docker, you can set up open source projects easily on your machines compared to if you don't know what Docker is. All right. That's the high level of why we want to go through Docker. The code is present here on a track called Docker end to end on projects.100xdevs.com. Today we'll try to cover some beginner stuff, as in enough to do Docker in most cases. Tomorrow we'll do some advanced things which are they're not needed for a long time and very theoretical things. But today is pretty actionable, which basically means if you go through today's class, you're pretty much okay with Docker for a long time. If you want to dive deeper into some internals of Docker, not exactly internals of Docker, some advanced concepts, then you can attend tomorrow's class as well. Feel free to skip tomorrow if you feel like it, because those things are not really needed. You don't really have to worry about them for a long time. Let's kick things off. First thing, why Docker? Why do you need Docker? Why was it introduced? And I'll give you some jargony answers right now. These will come back to you later on when we reach Kubernetes and container orchestration. But Docker, or more specifically, containers, there's a big difference between these two. This is a company. This is a more generic concepts on machines. Both of these things are sort of important for a few reasons. Reason number one is if you've heard of Kubernetes or generally something called container orchestration, you cannot understand this until you understand these. So that's the first reason. Unless you understand Dockers from the high level, actually not even from the high level, really well, you won't be able to, you'll get very confused in Kubernetes because there are 10 different things to learn here. This is a prerequisite for that. So number one. Number two, if you want to run processes in an isolated environment, and what isolated environment means we'll come to very soon. But if you've seen my Replit video on YouTube, if you've heard me build LeetCode in the past, I have kept on saying one thing, which is you should run code in an isolated manner whenever you're building something like Replit or LeetCode. Docker lets you do that, or more specifically, containers let you run code in an isolated environment. There are many benefits to this, to run code in isolated environments. I can name a few. If you have one very big EC2 machine, if you have isolated environments, you can run 10 different applications on them, and those applications can't talk to each other. They're very isolated. So that's the benefit of using containers. There are 10 different benefits, that you'll eventually understand as you begin to containerize applications, but these are the ones that really pop off initially. Starting projects locally and starting auxiliary services locally. What do I mean when I say projects? I mean any open source project. If you look at our website, if you look at cal.com, if you look at dub.sh, I'm unsure about dub.sh maybe, but most projects will have what's called a Docker file. They will make it very easy for you to start the project locally, so you can start contributing using Docker. So that's another benefit. And what do I see when I say what do I mean when I say auxiliary services? These are things like Postgres, Docker. In fact, there is a whole video and track that's called Actionable Docker somewhere here. Let's see. This one right here. There is a video as well that basically takes you through how you can start auxiliary services locally using Docker. So that's another benefit of knowing Docker and understanding it. These are just like few of many benefits of Docker. We'll see a lot of these as time goes by. Number two, before we start and understand Docker, we need to understand what containerization is. As I said, this is not Docker specific. Docker isn't the only technology that lets you create containers. Containers are something you can create on a Linux machine without Docker as well, although Docker is the most popular sort of framework or container runtime that you will usually use. What are containers? If you look at the photo, it's basically a container, right? It's sort of a bowl which has not just your code, but a bunch of other things usually. A container, specifically in the context of computers or Linux machines, is an environment or the best way I can explain it, it's a mini machine. It's a small machine running inside your very big Mac machine. If this is your Mac machine, you can start a small, let's say, Linux box inside. That's not technically true. You're not starting a Linux box, but you can think of a container as something which has some code, as well as a file system, as well as a network, very similar to a small machine running on your very big Mac machine. Containers are a way to package and distribute software applications in a way that makes it easy to deploy and run consistently across different environments. It's a way for you to package various softwares, Node.js, Golang, Rust, a terminal, let's say, Bash to talk to terminal, file system where you have a bunch of files and folders, your actual code. Packaging all of this together into a single thing is what's called a container. Nuanced. This is not, they're like technical. So there's this difference between images and containers. There's like very subtle difference we'll get to eventually. This isn't technically true, but for now, think of it as a single place where you put a bunch of things when you want to run them on your machine. They allow you to package an application. Here's what is an application. It could be your Node.js application. It could be your Paytm project that you have created. You haven't yet containerized your Paytm project, but we'll see today how you can do that. Along with all the dependencies and libraries into a single unit that can be run on any machine with a container runtime such as Docker. So what is Docker? It is a container runtime. What is a container? Something in which you can package not just code, but 10 different things and give it to someone else to run. The key thing here is be run on any machine and run consistently. These two are important. This basically means that I can create a container for my Paytm backend on my Mac machine. I can give it to you and you can run it on your Windows machine in a single command. Why is this important? Because this might have been you over the past few weeks. If you're on a Windows machine, you've been extremely frustrated with some dependencies that don't work for you. They work for most people on the cohort, people who have Macs or Linux machines, but they don't work for you because Windows is just not the most developer friendly environment. Everyone has a different operating system, and steps to run a project can vary based on an operating system. If I give you a Paytm backend to run, then you have to first install Node.js, then install MongoDB, then maybe install some other dependency that I'm using, Postgres, and then you can start the project. That process might be very easy for someone on a Mac, very difficult for someone on a Windows machine, which is why containers are useful, because you can give the same container, let's say this is a container, to a Mac user or a Windows user, and they have to just run a single command. This thing has the JS code, Mongo, Node.js, everything installed. So you don't have to take an extra step to install Node.js on this Mac machine. It comes bundled in this container. So this container can be run on different operating systems consistently. That is what a container lets you do. Extremely hard to keep track of dependencies as project grows. If you're on a Windows machine and I give you, a Node.js project today, and tomorrow tell you we also have a Golang microservice, and then day after I say Rust, we have a Rust project as well. You have to install all of these on your Mac machine. It's very hard to keep track of what dependencies you have. And let's say tomorrow I fire you from my company. It's been happening a lot now. Then you have Rust on your machine, you have Golang on your machine, and you no longer need to work on the project. It just stays there. Versus if I just gave you a container, you could simply start this container. Whenever you get fired, you just delete this container. Very convenient. Lastly, benefits of using containers include, and this is like a very brief mental model of what a container is. A Mac machine can have, a container inside which a React application is running, a container inside which a Node.js backend is running, and let's say a third container where MongoDB is running. Rather than running them natively on the machine, you can run them inside multiple containers. Let you describe your configuration in a single file. If you look at this diagram, there is a React application running, right? You can, in a single file, write ke bhai, how can you create this container? What does this container need? It needs Node.js, NPM. It needs your React application code. That's all. You can write a single file. Okay, bhai, please add Node.js, please add npm, please add, copy this code base, and then run npm run dev, and you have a container running. Similarly, Node.js application. Similarly, MongoDB as well. If you have in the past started MongoDB locally, you ran a single command, and that specific project came up. And whoever had written, let's say, the MongoDB container or image, they wrote it in a very big single file. So a single file to describe your configuration can be done in isolated environments. This code is very isolated compared to this code. What does isolated mean, Harkirat? It means it's very hard for this guy to talk to this guy and vice versa. It's very hard for this guy to take the complete CPU of the Mac machine. It's very hard for this guy to talk to this MongoDB database unless you provide it a way to communicate. So it gives you very restricted permissions on this guy, and this guy. Makes local setup of operating of open source projects a breeze. You run a command, just like you can run React project, a Node.js project. You can run the whole cal.com code base in a single container by running a single command. You don't have to worry about first installing MongoDB, Node.js, so on and so forth. And lastly, as I said, you can easily start auxiliary services. That's all for this slide. That's what containerization is. There are some references at the very end. If you might remember, this is how you start a MongoDB container if you've gone through the past lectures. So it's a single command to start something like this. A MongoDB container can be started by running a single command on your Windows, Mac, Linux, does not matter. Docker isn't the only way to create containers. Keep that in mind. Docker is just the most popular runtime for containers. History of Docker. I don't follow the founders of Docker, so this guy might have changed, but I think this is the most up-to-date founder of Docker. I could totally be wrong here. I found this photo here on a reference. But Docker is a VC-backed company, so it's not completely an open source, and it's an open source project. It's not free though. They're a company. They sort of envisioned, they envisioned a world where containers would be the mainstream. Containers would become mainstream, and people would deploy their applications using them. And hence they sort of back in 2014 introduced Docker. It has changed a bit since then. But today Kubernetes is sort of, written not on top of Docker, but, requires Docker if you're using Docker as your container runtime. So a lot of products were built on top of it. These guys built the base layer. Okay, bhai, people will in the future deploy applications like this. So let us build something that lets people create containers. Back in 2013, today they're a pretty big company, make a lot of money. We'll discuss later how they make money, but yeah, most of their code is open source. Most open source projects that you see on GitHub will have, some variation of Docker in there, and you can start those projects locally by running a single command. All right. So here, let's quickly install Docker. The first thing you have to do when you're learning any new technology is install it locally. I'll wait for 2 minutes or 3 minutes. I did announce you should do it. I'm unsure how many of you have done it, so we can take a breather here and you guys can install. But here is a link to install based on what operating system you're on. There's also something called Docker Desktop that, will make your life a little bit easier. Initially, I also have it somewhere here. Lets you see everything in a GUI. So feel free to pick and choose what you want to install. By the end, you will know whether or not you have Docker installed. If you can run the Docker command in your terminal, or if you're on Windows, then your command prompt, or if you're using Git Bash over there. This is where you need to reach before we proceed on the slides. You need to be able to run Docker, and you should see something over there. It should not say Docker does not exist. Let me quickly do a poll, and let's see how many people actually followed the announcement and installed it. Do you have it installed locally? Are we good to go? Wow, that's surprising. That's a surprising number. So 80% already has it installed, which I'm very happy about. Good that you guys came prepared. I'll wait for, as I said, a minute or two. Then we'll proceed. Let me talk a bit about the history of Docker. I don't know, something else. But yeah, then we can proceed. So what can we talk about? Let me just show you, a lot of projects and Docker files inside them. So if you look at cal.com GitHub, you'll find, oh, they don't have it here. They have it in like some other organization or some other repository, if I remember correctly. Yeah, there you go. They have like a Docker repository inside which they have all their Docker files. I don't know. I think it's somewhere here. Picked the wrong organization. Let's see. There you go. So this is the place where they have their Docker file. They're a very big company, which is why it probably makes sense for them to have it in a different repository. I don't know. Most projects, you'll just find it in the same repository. So if you look at app.100xsteps.com, this Docker file was added by someone. I think there was a bounty on it as well. But basically, this is something you can do by the end of today's class, is add this thing called a Docker file in a project. And it's pretty small, as you can see. And it lets you, anyone, if you want to now start this code base locally, you can start it in a single command. You'll find this very popularly in, a lot of code bases, this top level docker compose.yaml and this Docker file. All right. And that's also a decent contribution to make if you're ever contributing to a company and they don't have a Docker file there. Cool. I think we can proceed at this point. For the people who weren't able to install, would urge you to quickly install. I don't think we're reaching commands very soon, but we will. So yeah, I would urge you to do that. Let's move on to the next slide. Let's understand some jargon. You can go very deep in Docker. Docker lets you do 10. It lets you do these things only, but if you want to understand the architecture of Docker in depth, we're not doing that today. We'll understand the things that you need to know very well. A few things that you don't need to know as well, but they're good to know. And then we'll go through some jargon that will eventually come back. This is the general flow of when you're running Docker locally. Specifically when you're running Docker locally to start something like MongoDB. If this is your Mac machine and inside which you run the command docker run Mongo, let me quickly show you that. If I run docker run Mongo, we've run this in the past. If you might remember, we've added a port mapping over here, which don't worry about what it is. But this is something we've done a few times. I've asked you to do in the actionable Docker class that we had. What happens when I press enter over here? MongoDB begins to run. It's not running right now because this port is already taken. I already have something running on that port. But if I change that port mapping, you'll see Docker starts running for me. I see a bunch of logs. Sorry, Mongo starts running for me. I see a bunch of logs. What exactly is happening under the hood? Number one, the terminal is actually talking to something called the Docker engine. What is the Docker engine, Harkirat? This is basically the thing that's running on my machine. This, if I open my Docker GUI, this is a GUI or a graphical user interface or an application that is showing me what Docker has. It says Docker has, these containers running for you, Harkirat, and these images and a bunch of other things. Similarly, this just how this GUI is getting this information from somewhere. This terminal is sending this information to somewhere. That somewhere is the Docker engine. It's basically the code base that you look at if you open Docker on GitHub. It's the thing that actually runs and lets you create containers, start containers, create images. It's the thing that you install when you go to this website and click on install Docker engine. The actual software of Docker that's running on your machine is what's called the Docker engine. You can talk to the Docker engine in various ways. You can talk to it via a terminal. You can talk to it via this GUI. You can talk to it via REST APIs as well. These are all clients as to how you talk to it. In the end, this engine is what can start MongoDB containers and do a bunch of other things. But it can be called, or a command can be sent to this from various places, from either a terminal, or this Docker desktop, or a terminal, or you can also send REST API calls, although that's a little difficult to set up. But yeah, you can talk to this engine from various places. What happens when I run Docker run Mongo? A command goes there, it talks to this engine and says, bro, please run MongoDB locally. This person wants to run Mongo. And the engine basically checks, okay, bhai, do I have this Mongo image? Do I know what Mongo is? And if this is the first time you're running this command, you of course don't have the Mongo image. Harkirat, what is the Mongo image? It's basically a container that someone has created and pushed out there. It's not a container, it's an image. Very big difference between both of them. But it's basically similar to code base, right? If I want to start cal.com locally, my machine will first get it from GitHub and clone it locally, right? Similarly, if I want to start MongoDB locally, my machine will first, or this Docker engine will first, get this image from somewhere, which we'll discuss what this is eventually, the Docker registry. And then it will start the container locally. So there are a few components here to look at. Number one, the terminal, this thing right here where I'm running this command. Number two, when I run this command, This command reaches the engine, and the engine first fetches Mongo from the Docker registry. This takes some time, like can take 5 seconds, can take 50 seconds based on, how good your internet is. It fetches what's called an image from here to here, and then it runs it over here. This is the general flow of what happens when you run Docker run Mongo. But I've talked about a few things. Let me explain all of them in a little bit more detail. Specifically, let's understand 3 things: the Docker engine, the Docker CLI, and the Docker registry. These are good 3 things to know. Eventually, which is basically this thing right here, this thing right here, and this thing right here. Eventually, we'll understand containers as well. But for now, let's understand these 3 things slightly in depth. The Docker engine. Docker engine is an open source containerization technology that lets developers package applications into containers. It's basically the pitch of Docker. What Docker does. What does it do? It allows developers to package applications into containers. What are applications? Could be cal.com codebase, could be MongoDB. All of these are applications that you can package into containers by using Docker. Or more specifically, that's what the Docker engine does. Containers are standardized executable components combining application source code with the operating system libraries and dependencies required to run that code in any environment. Slightly jargony of a statement, but what does it say? It says a container lets you get your application source code, which means cal.com source code, plus the operating system libraries, whatever library you have in your machine that lets you do ls, or the complete file system of your machine, depending on what operating system you are on. And lastly, dependencies, Node.js, NPM. These are just the 2 dependencies that you need. But let's say, your project had Rust as well. Then this dependency as well. All of these can be packaged into a single thing called a container. Docker engine lets you do that. It lets you package things together. CLI, command line interface. Name is pretty self-explanatory. It is basically this thing right here. When you run Docker and press enter, this is what's called a command line interface. It's basically, so this is the npm CLI, npm command line interface. If I press node here and press enter, this is the node CLI. And similarly, this is the Docker CLI. It's just a client that lets you talk to the Docker engine. That's what the command line interface stands for. And lastly, the Docker registry. This is sort of important eventually. This is a place where people have stored very popular code bases already, very popular applications already. For example, MongoDB. If you go to hub.docker.com, this is very similar to GitHub, and it lets you find a bunch of images, not code bases. GitHub lets you find code bases. This guy lets you find, for example, if I search for Mongo here, it shows me the MongoDB document database provided high availability, easy scalability. This, as you can see, it has 10K stars, very similar to GitHub. It has 1 billion downloads. So this thing is called a registry. Hub.docker.com is one registry. There are many Docker registries similar to how there is GitHub, then there is GitLab, then there is Bitbucket. There are many code registries as well. There are many Docker container registries as well. Hub.docker.com is the one that the Docker folks own, but Google has its own, AWS has its own. Depends on where you want to push your code, but most of the popular code bases are present here on the Docker registry. If you have an application that you want to deploy in AWS, then it's usually a good idea to use the AWS registry. But most of the code bases that you'll be using, for the next few slides, for example, MongoDB, you can find here on the Docker registry. Cool. That's as deep as you want to go as a full stack engineer in Docker. You can go deeper, but this is more than enough to be able to, do everything you need to do for many years. Two more things you need to know are images and containers. So what do we understand? We understand Docker engine, Docker CLI, and Docker registry. The one other thing we need to understand is this thing right here that's running, the container. And another thing that I was talking about called the image. So images versus containers is a popular interview question, something you need to know. A Docker image is a lightweight, standalone, executable package that includes everything needed to run a piece of software including the code, a runtime, libraries, environment variables, config files, everything you need to run MongoDB packaged together is what's called an image. A good example of an image is if you've ever tried to install Ubuntu on your Windows machine, you might have taken an ISO image from your friend. Very similar to that. An image is a slightly more lightweight than that. If you install Ubuntu from a friend, it has 10 different things that a container does not. Containers are supposed to be lightweight, but images mentally are the same thing. Okay, they are not just your code base, similar to what's present on GitHub. This Mongo image is a lot of things on top. It has a bunch of libraries that MongoDB needs. It has a bunch of libraries, dependencies, environment variables, and config files, and your actual source code. It has more than just your source code packaged together, similar to when your friend gives you a pen drive with Ubuntu in it. It has 10 different things that let you see the GUI of Ubuntu and create files, so on and so forth. A good mental model for this is your code base on GitHub. If you're comparing images and containers, then images are your code base on GitHub, and containers are when you actually run the code base on your machine. The difference between images and containers is, okay, if you run Docker run Mongo 3 times, let's say, then only one time you will fetch the image from the registry, and you can run it 2 times, 3 times, 4 times, as many times you want. You might run MongoDB on this port and then start another MongoDB instance on this port. You can run a Node.js application 10 times, right? You can run a React application 10 times. But you need to pull its image. You need to pull its all the dependencies and the source code from the Docker registry just once. So that's the difference between an image and a container. Don't worry too much about the commands that I'm running right now. But if I run Docker images here, you will see I have a bunch of images, including Mongo. I have a single Mongo image over here. That is what this image is right over here. This image that you see when I run the Docker images command, you won't see it. So don't try to run this command locally. But just to understand what all images I have a Mongo image, which is similar to this green thing right here. If I type Docker PS, it will show you the containers that I'm running. And as you can see, I'm running 2 Mongo containers. I just ran one in front of you. I closed that one, but I was running 2 before this, before the class started, which is why you can see it says 5 hours ago, Harkirat had created a Mongo container. And this is another Mongo container. This one is running on port 27018. This one is running on port 27017. So I can start multiple containers. But I only have a single Mongo image over here. I don't have to pull it twice, right? If I have some Node.js code, I can pull it in my file system over here by doing a git clone, right? I can pull it once. I can run it 10 different times. I can start a React application on port 3000, 3001, 3002. I can start it many times. That's what a container is. I need to pull the source code only once. That's what an image is. Do we understand this? How were the first 30 minutes? Pretty theoretical. But are we good to go? Do we understand the 5 jargons that we've just learned? %. Good, not great. Let's see what do we have to discuss next. Port mapping, common Docker commands, Dockerfile. All right. So take a breather. Let's open chat for 6 minutes and we will restart and understand port mappings after that. Make sure you have Docker running locally until then. Let's take a small breather and understand what's up. Any specific questions that you have? What's up? 15%, what's up? Let's see. Quick recap. Okay, yeah, I guess it's just a recap. Cool. Let me start from the top and quickly recap things for the next 5 minutes. What I mentioned was, let me just go to Excel draw here. What we've discussed in the last 30 minutes is that if you have your Mac machine, you can run code directly over here. Node index.js. You can run MongoDB directly over here. I don't know how many of you tried running MongoDB, but the thing that you have to run if you want to start MongoDB locally is this mongod command. Or you can start both of these things by running docker run some image name over here. And similarly, you can start MongoDB locally by running docker run mongo. Docker is a container, call it runtime. It's something that lets you create containers. It's something that lets you run containers. It's something that lets you manage containers. And the way Docker works is that it has what's called an engine, which has something called a daemon, which is basically the thing that's listening. If you want to really know what's happening under the hood, it has a daemon. Daemon basically stands for, something that's listening on events. And this guy is listening for people to tell it, okay, bro, please create container, or please start container, create image or start container. And there are various ways you can talk to the daemon. One of the ways is by creating a terminal. Going to a terminal and typing docker, whatever, run mongo. Or you can go to this docker GUI, which I just showed you, which is this thing right here, that lets you at least view containers. I'm sure there's an easy way to create them as well by clicking buttons. And you can also talk to this daemon and tell it to start containers by hitting an API. Where you hit the API is a little weird. You don't get like a HTTP endpoint to hit it unless you tweak it a bit. But you can also send like what's called a REST API call to the daemon and tell the daemon, bro, please start a container. You can send a post request only, it does not go to localhost : something. It goes to what's called a socket URL. And you can very easily convert this socket URL to an HTTP endpoint. But yeah, the basic point is this daemon can be talked to in various ways. The one that you'll usually do is, this terminal through which you talk to the daemon. And what do you usually do when you're talking to the daemon? You usually do two things. You either create an image and push it to Docker Hub. This is what the person who has created this Mongo image did. Or you start containers locally using other people's images or your own images. These are the two things that you usually do when you're creating using Docker locally on your machine. Eventually, we will see how you deploy to AWS machines using Docker /Kubernetes. But this is something that will come eventually. For now, locally, we'll be doing just these two things. All right. That's a brief of what we've discussed. The big thing to know until now, the big thing that will confuse you is the difference between images and containers. If you understand this, you're sorted for the practical part of this video, and then I'm happy to dive deeper into theory later on. Shall we proceed, guys? Are we good to go? I think even either way we're going to proceed, but let me just see where the poll's at. All right. Beautiful. Let's proceed. One more thing before we proceed that will confuse you eventually is something called port mapping. If you remember, the way to start MongoDB locally was not simply docker run mongo. It was docker run, ignore this -d, -p, and a port mapping. The reason this is important for you to give is because I've said this a few times. Okay, these containers are very isolated. This is my Mac machine. Whatever container you're starting, Mongo container, React container, they are very isolated. What does isolated mean? It means that even if this Mongo container is listening on port 27017, it is listening on its own port. As I said, this is sort of a mini machine, which means this has its own set of ports. This 27017 port is different from the Mac machine's 27017 port. If I go in my browser to localhost :27017, it will hit my Mac machine's 27017 port. Right now I'm running this Mongo container, which is why you see Mongo logs over here. But if I did not have this port mapping, you would see nothing over here, even though I'm running Mongolib locally. Let me stop all the containers. So I start from a clean slate, just like you might. Okay. If I go to localhost colon 27017, I'm going to my Mac machines localhost colon 27017, which is different from any container's port. This container has its own set of ports. This container has its own set of ports. It is not necessary that if this container is running something on 27017, then if a request comes on my Mac machine on the same port, it will not reach here. Unless I specifically add a port mapping, it will not reach here. I might just be running node index.js natively on my machine, which is listening on this port. And this Mongo container is running on its own. This is also listening on its own 27017. This is running on its own 27017. So whenever you start a container, you have to specifically tell it, okay, bhai, if there is a request coming on this Mac machine, please transfer it to this port of my machine. This is what's called a port mapping. If you look at the command again, it says docker run, please map this port of my Mac machine to this port of this container and then start the container. It says run this container, but please add this port mapping so that any request coming to the Mac machine's port gets routed to the Mongo container's port. This is exactly why if I just run docker run Mongo, you will see MongoDB started to run over here. But if I go to localhost colon 27017, I see nothing. But if I run docker run -p 27017 colon 27017, which means Mac machines this port, please go to Mongo machines this port and press enter, then I will see something on localhost colon 27017, because now this request is getting routed to this request because I mentioned that when I started the container. Harkirat, what happens if you change the second one to 27019? There is nothing running on 27019 on this Mongo container, and hence my machine will basically arrive at nothing. It will start to hit this endpoint of the Mongo container, which is not running anything, which is why I won't see anything. Harkirat, what if I change the first one to 27090, let's say? Then your Mac machine's 27090 is routing requests to the Mongo container. So if I go to 27090 over here, I see MongoDB. That's what port mapping is, and why it's useful is because Docker by default will run these in very isolated environments. If you want to expose some functionality, you expose it via port mappings. A lot of times you don't need to expose a container. You just want to start a container that does some random task, and you don't need the world to be able to talk to it, in which case you don't have to add a port mapping. Do you understand what a port mapping is and why we need to add this whenever we are starting, let's say, a Mongo container or a Node container? Again, if you have an application that doesn't need to talk to the internet, then it can just independently run. You don't need to add a port mapping over there. All right, beautiful. So let's proceed in that case to some common Docker commands now that I've been writing on my side, but you guys maybe have not written. So let's look at the CLI, explore it a little bit, and see what commands are commonly used when you're using Docker locally. All right. So I would urge you to, open your terminal now and run some commands with me. 1 second. The first command, maybe before you run the Docker images command, just once for me, run docker run Mongo. You don't have to add a port mapping, but just run this once, docker run Mongo, and press enter. What this will do is it will pull the Docker image from this Docker hub so that you have it locally. This thing right here that I was talking about, the green image right here, so that you have some image on your machine that you can explore as you're running some of these commands with me. So just once, run this. When you run this the first time, it'll show you some logs that say pulling the image from Docker Hub, something like that. So just quickly do that. And then we'll try to run these commands. I'll give you guys 30 more seconds and then we'll proceed. Let me quickly look at Q&A if I can get to it really quickly. Unable to find Mongo locally. If you don't have it, try running docker pull Mongo. I would have hoped it would just pull it by default. I thought when you run docker run, it just pulls it directly, automatically. If it does not for you, it seems like it does not in your in a few cases for people on Windows. So just run docker pull Mongo and that should pull the MongoDB image for you. For some people who see some socket error, we're not able to talk to the Docker engine, run sudo docker and then the command rather than running docker. So docker, whatever, run Mongo. Just add sudo in front, give it your password. That should fix your error. All right, I see a few people who see that. Cool. Let's proceed. If you were able to do this, if you were able to run docker run Mongo locally, now if you run Docker images, it will show you all the images that you have locally. I have a few of them, ignore all of them. Which is the one that you might be having locally? It is this Mongo image. This is this green thing right here. Your Mac machine or Windows machine now has this image locally. You can now run this as many times as you want. And that is what will start a container. So hopefully the difference between images and containers is clear. And we understand what Docker images does. It shows you all the images that you have locally. I have a few of them which you can ignore. The one that you will have right now is this one right here. And as you do a lot more coding and use Docker more effectively, you'll have like a lot of these on your machine as well. The next command is docker ps, which is basically, it will show you all the containers that you're running. These three blue things right here. So if you run docker ps right now, you will most probably see no container running locally, because even though you have the image, you have not yet started the image. The way to start the image, as I've talked a few times now, is docker run. If you want to add the port mapping, feel free to add it. If you don't want to add it, that's fine as well. But docker run Mongo should start the image in this terminal. Now you have a container running. If you open another terminal now and run docker ps here, you will see you have a container running. If in one container you ran this docker run Mongo and in another container you run docker ps, because if you exit this container, the container will stop. Sorry, this terminal, then the container will stop. So you need two terminals for this experiment. Or what you can do is you can run docker run Mongo, but add a -d argument here. It basically means run it in the background, run it in detached mode so that this terminal becomes free. So if you run docker run Mongo with -d, it will start a container in the background. And now you can run docker ps in the same terminal and see you have one Docker container running locally. Harkirat, how do I start 3? Just run the command again. If you run it 3 times, you will have 3 Mongo containers running locally. Doesn't make sense to run 3 containers, but you get the idea. If you want to, let's say, I don't know, have a different MongoDB instance running for one application, different for another one, then you can start this many times. Of course, this won't work at all because we haven't yet added the port mapping. So ideally what you should run is docker run -p, a port mapping, and then -d Mongo. And then this one can now be visited on your machine. That's what docker ps lets you do. As time goes by, you'll create more of these, and then, if you want to get rid of them, then you will kill a lot of them as well. So maybe the next command we should quickly look at is docker kill, so that you can clean up your containers quickly. Docker kill followed by this container ID is what will kill that container. So just run this command a few times. And now I again have 0 containers running on my machine. Harkirat, what if you want to get rid of the image as well? Let's say you got fired from the company. You no longer need Mongo at all. You don't have any use case for Mongo. Then it's a good idea for you to clean up this green image from your machine as well. It's just taking unnecessary space. So you can remove images as well. I forgot the command, but I think it's docker remove mongo or something like that. No such container. No. Docker. I mean, you could happy to figure it out. You can also use if you really want to, quickly do this, you can delete it from here, GUI, or I'm sure there is a easy way to docker. Okay, time to open chat. What's the way to remove an image, guys? RMI, I think. Docker RMI. Yeah. So docker RMI Mongo. There you go. Oh, it will say it's not running, so you have to force it. And when you do that, it'll clean up the Mongo image as well, which basically means this green thing goes away. And if you want to restart it, now if I run docker run Mongo one more time, it'll say unable to find this image locally, and hence it will start to pull it from Docker Hub. Cool. That's the life cycle of how you start and stop and remove container and images from your machine. What are the commands we have understood? List all the images, list all the containers, and then docker kill to kill a container, docker kill to kill a container, and docker RMI to remove an image. Do we understand these four? Are we good to go? Of course, it'll take some time to practice, and as you just saw, I forgot the RMI command, so feel free to. If you don't remember them by heart, it's fine. But you need to know what all you can do with the Docker CLI. All right, great. This is great, beautiful. Let's proceed. In that case, the two other commands you need to know are docker run and docker build. Docker run, I'm sure we know many times now, so I'm not going to reiterate. It's just how you start a container. Docker build is an important one we will eventually get to. This is when you start to create your own containers. Right now, we are just using someone else's container locally on our machine. Eventually, you will create containers of your own, which is when docker build will come into the picture. For now, we can ignore. And then I have a few other extra ones. Docker kill we have discussed, and docker exec is something we'll come to eventually in the slides. All right. These are the 6 commands you need to know. The important ones right now are these 3 and maybe docker kill. All right. Let's proceed and understand how can you create images of your own now. This is, not where you will spend a lot of your time. These Docker files are created just once. As I showed you in the code base of app.100xdevs.com, someone created this once and then it just stays there forever. So it's not, a recurring effort to update these a lot of times. They get changed not very often. But if you have a project where you want to containerize that project, let's say you start an open source project where you want other people to contribute to it, you should add a Docker file to it. You should make it easy for other people to run it on their machine by running a single command. You should, if you want, you can deploy it on, Docker Hub as well, so that other people can pull your code base. If you create a database of your own, it's a good idea for you to create a Docker file for it, which is a single file, which will describe how can you create this image. That's what a Docker file is. But let's read through the definition. It says, if you want to create an image from your own code, if you create a MongoDB comparator, if you create your own open source project, if you want to create an image for that you can deploy here on Docker Hub, that you can push to Docker Hub, you need to create a Docker file for your application. It's a single file where you can describe everything. Okay, this is how you start Mongo containers. This is what you need to start a Mongo container. You need Node, you need an NPM, whatever dependencies you need. And this command you need to run and it will start the container. That's what the Docker file is. A Docker file is a text document that contains all the commands a user could call on the command line to create an image. If the way to start, your Node.js application on a Mac machine is number 1, install Node.js. Number 2, do a git clone of the project. Install Node, do a git clone, and then, do an npm install, and then do an npm run build, and then do a node dist/index.js. If these are the 5 steps that you take to start your application on a Mac machine, you just have to write the same commands in a Docker file so that you're able to create a single image, something similar to this, that people can run on their machines. But that's jargon. So let's try to read through this and look at what a Docker file looks like for a basic Node.js application. So what we're going to do is, there is an open, not an open source project. There's a simple code base that I've deployed, which has Express as the backend and Prisma as the ORM, Postgres as the database. We'll try to containerize this application. We'll try to add a Docker file over here so that if someone else wants to start this project on their machine, they don't have to install Node.js. They don't have to go through any README. They will run a single command. It will start for them. For that, we need to create a Docker file for this code base. So let's quickly clone this code base locally. Oh, we're at time-ish, so let's take a break as well. But yeah, that's what the next step is, creating a Docker file. This is basically the same thing that someone did for this CMS project as well a few days ago. We're doing it for a slightly smaller project. The one that I sort of created today, all right? Let's do a poll. Do we want a break? Yes or no? Do we want a break? I'm pretty good, so I can go without a break. First time I'm seeing no win, even though it's marginally. Let's take a small one. It's pretty much 50-50. So let's take a small break and then we'll proceed. And by small break, I mean 3 minutes. 3 to 5 minutes, take a small break and then we'll proceed. Any questions until then? I'm going to open chat. All right, a lot of questions. Let me speed through them. Difference between virtual machine and a container. A virtual machine is what you run on AWS. When you go to, so a virtual machine is basically, so there's something called a hypervisor. What do you think happens when you go to an EC2 machine and start it? It's not like they have 20 EC2 machines and they give you one. They have one very big, what's called a hypervisor, which has 100 GB, 1000 GB space, 1000 GB RAM, and you get some small part of it. So a virtual machine is a virtual machine on top of that hypervisor. It's a small machine that has access, that gets those resources for that time. Versus a Docker container is something that you might run on a virtual machine or, on your own Mac. It's much more lightweight compared to, you getting a virtual machine. When you go to AWS and start an EC2 instance, that's a virtual machine. Why do they have a virtual machine? Why they don't give you a complete machine? As I said, shared resources, right? They don't want to buy 1,000 T2 large machines and then 1,000 T2 X large machines. They want to buy a very big hypervisor and then, create virtual machines on top. Do we need to write Docker file in every project to make the project openable in a container? Yes. If you want to make any Node.js project, any Rust project, any Golang project openable in Docker, in a container, Docker isn't the only way to create containers, but one way. So if you want to operate in a container, you can do it using Docker or by creating a Docker file. Is downloading MongoDB, does it download on my machine or in the container? It downloads an image on your machine. It does not download the MongoDB binary. It downloads this image, which of course has the MongoDB code base inside it. And when you remove this image, that MongoDB code base goes away. Images is similar to npx create. Okay, great question. Oh, sorry. Should we? Oh, sorry, there's a better question here. Images is similar to npx create wheat at the rate of latest, and container is same to npm run dev. You can say that. And भाई speed बढ़ाओ, ऐसा लग रहा है 0.5 में पढ़ रहे हैं. Okay, let's see. Do a quick poll. We'll start at 8, but let me do a quick poll. How's the speed? Slow. Okay. Fast. All right. Let's do this poll and then we'll proceed. And I'll change the speed based on the results of the poll. Okay, so 70% okay, 20% slow, and then 7% fast. So I'll try to go a little bit fast, but not too much. And with that, we're at 8. So let's proceed. Let's start to write a Docker file for this Node.js application. Let's quickly clone this project locally now. So I would urge you to go to github.com We post this in chat. So if you want to follow along, just clone this project locally. And open it in Visual Studio Code. Maybe try to explore it a bit. All right. Let me quickly take you through the project, but it's basically a very simple project. You might see a bunch of these errors because we have not run npm install. Feel free to run it, although it'll give you some errors eventually. So maybe don't run npm install just yet. I'll share what those errors are. It imports Prisma client from @prisma/client. It imports Express from Express. Initializes an Express application. Adds a body parser, JSON parser, so that you can receive body from the user. Initializes a new Prisma client. And then has two endpoints. One very simple endpoint, which is usually called the health check endpoints, that simply returns a message that says the server is healthy. And then a post endpoint that actually creates a user and then returns back, you're done signing up. This is where we use Prisma to actually, put something in the database. Other than that, there are standard Prisma files, migration files. And the package.json, if you look at, it has a script over here called build, which does nothing but tsc-p. That's what the application is. If you want to try it out locally, you can run npm install, followed by, npx prisma generate to generate the Prisma client. If you want to do it, feel free to do these two steps. You don't have to, but npm install, npx prisma generate, and then npm run npm run build to start the project, build the project, create dist/index.js, and then node dist/index.js to start. You don't have to do this. If I went too fast, it's fine. I'm just showing you, if you wanted to start this application locally without using Docker, this is how you would start it, right? You would first run npm install, then run npm run build, and then run node dist/index.js, and that should hopefully start the application on port 3000. You should see message healthy server over here. This is the non-containerized way to start this application. This is how you might be starting applications on your machine until this point. Now we need to start it in a container. And for that, what you have to do is, as I said, create a Docker file. So that's the first thing you have to do. In the root folder, doesn't matter where you create it, but let's create it in the root folder right here and call it the Docker file. And here you have to describe almost the same steps that I ran in this terminal. The steps that I was running in this terminal, npm run build, npm install, npm run dev, or node index.js, I just need to write them here one by one. And that will tell Docker, this is how you start this application. Let's look at the Docker file for this specific application. If you go back to the slides, already created the Docker file. As you can see, it's less than 12 lines of code. And a lot of this might just feel very familiar. Npm install, npm build, node dist/index.js. So let's look at and understand this Docker file from the top. The first thing you have to do whenever you're defining a Docker file is define what's called a base image. You have to say, this is the base image from which we will start. Now node:16-alpine is a very famous image on, again, hub.docker.com. If I go here and search for node, you will see there's a node image over here. It has various what are called versions or tags. And the version that we are using is 16-alpine. There are many Alpine versions as well, but this is the one that you can start. This basically means node 16, and Alpine basically means a slightly more trimmed down version of Linux. So you don't get like a 1 GB image, you get like a very small 200 MB image. But doesn't matter. You can start, any Node.js base image to start from. You can select node:latest. You can select node:slim. Really depends on you what version of Node.js you want to start. What is key here? The key thing is every Docker file at the top needs to have okay, bhai, this is our base image. Now, since some people have already created a base node image, which basically means this has Ubuntu, let's say, and Node and NPM and NVM, they've already installed all of this in this base image. So we can just start from there. We can be like, yeah, this is our starting point. And then from there, we will run all of our application specific commands. If you want, you can select Ubuntu here. You can be like, I don't want Node. I'm going to start from Ubuntu. And then you can run a few commands to actually install Node.js in this image. So if you want, you can start from a scratch, fresh base image as well, and then run a few commands to install Node.js. Or you can be like, yeah, this is our base Node.js image. We'll just start from there. We'll probably go with this one. So what's the first line you have to add? It is from Node : whatever version of Node you want. Let's say from Node 20 or 22, doesn't matter. Whatever version of Node you want. If you want a slightly leaner version, you can select the Alpine image. If you want full Node.js with, very big file system and a bunch of dependencies you might not need, then you can start from the base image. If you want, you can start from Ubuntu as well, and then, run whatever the installation steps are for Node.js and then continue. Or I would just, start from a base Node.js image. Harkiyat, what if you need both Node.js and Golang? Yes, in that case, you will start from a base Node.js image and then run a few commands to install Golang, or vice versa. You can start from a base Golang image and run a few commands to start a Node.js image. Second step, one important thing you will see in every Docker file is something called the working directory. This means, okay, you are going to run a bunch of commands after this. Where should we run these commands? That's what workdir means. Which means this is going to be your working directory for all the commands that are going to come. We're doing a few things after this. Before we do them, we tell the Docker runtime, okay, this is your working directory. Please put all the things here. Please run all the commands that I'm running in this working directory. And /app is a very common one. It basically means whenever the container starts, put everything in this /app. So feel free to define a name of your own, or if you want, workdir /app is a commonly used, mount for your application. Number 3, this one's important, and this is not the most optimal way of doing it. This is a very basic way. We'll eventually optimize this, but this says copy dot. This is important. This basically means if I run Docker build eventually, which will actually, look at this Docker file and start to create the image. If I run Docker build over here, if the third line here is copy dot, it means copy everything from this folder. That's what the first dot means, over to the working directory of the image. So what are the two arguments here? It is, okay, copy the source code of this application, copy everything over here, including node modules. Right now, it will also include node modules because you haven't told it, bhai, exclude node modules. So it will copy everything over to the working directory of /app. That's what the first 3 commands will do. If you leave your application here, if you don't write any more code, then your image will basically have all the source code and have the Node.js runtime. It won't do anything else, but these 3 things it will do. What you want to do is actually run it, which is why we'll look at the 4th command now, which is run. And here you can be like, by run npm install, run npm run build, run npx prisma generate. All the commands that you ran here in the terminal to start the application, you'll run the same commands in the image. These don't start the application. I repeat, these just build the application, bring all the dependencies, convert the TypeScript code into JavaScript code, generate the Prisma client. They don't start the application. We'll eventually come to how you can start the application. That's the first few commands. From what base image you need to start, working directory, where you want to source your store, where you want to run all of these commands. Basically, that's what the working directory is. Copy from wherever you're running Docker build, which is, this week 15 live, copy everything from here over to the working directory, run these 3 commands, and then expose a port because you want this specific container to, be exposed on a certain port, you know, okay, index.ts over here is listening on port 3000. So you have to tell the Docker container or Docker image creation, okay, this is the port that will be exposed on this specific container. And lastly, cmd node dist/index.js. This and this might feel very similar. Kirat, here you were running 3 commands. Here you wrote cmd to run node index.js. Why did you not write run node index.js? Why did you have to run cmd over here? That's a very good question. The answer is, okay, all of this runs when you create your image. I repeat, all of this runs when you create your image. Whatever you've written after cmd runs when you start the image, runs when you start the container. So all of this runs when you're starting the image or creating the image. This runs when you're starting the image or starting the container, which is why this cmd is different from run. And you write cmd on things that actually start the thing, actually start your application. You write run on things that bootstrap your application. If we were using Ubuntu over here, then here you would run, run whatever is the way to install Node.js on Ubuntu. So if you don't want to use the Node.js base image, then you would, whatever are the commands that this blog post gives you, which for example is, run this command. Then you can be like, run this curl command and then run source bash thing, so on and so forth. So you can run multiple things that bootstrap your environment. We're not going to, we'll just go with the base node image. But the cmd means what will actually start when the container starts. That is a brief of the Docker file for a node application. This changes, as you move to a next application. The command that to start there might be npm run start, or, if you start a Golang application, then, you might not have to do npm install, but have to do a go add or whatever is the way to add dependencies in Golangs. So this Docker file will change based on what file you have. But for a simple Node.js application, this is what it looks like. Is this the most optimal? No, you can optimize it a little bit more. We'll eventually come to that. The one thing you should keep in mind is, okay, when you're copying everything, you're copying over the node modules as well, which is something you shouldn't do. You shouldn't copy node modules from your host machine. Since you're running npm install, eventually node modules will come to your image. Don't copy them over from here. So either delete this or add node modules to something called a docker ignore file. So create a top level .docker ignore file, inside which you can add, node modules, dist, all the things that you don't want copied over. And you want the image to eventually generate. So feel free to add this .docker ignore along with the Docker file, which looks like this. As you can see, it's a little different. I forgot to put npx prisma generate here. Ideally, you should have npx prisma generate here as well. And if you want the solution, if you want to just copy it, it's present here. So you can just copy this. I think this and this look pretty similar, or they're exactly the same. But do we understand how can we create Docker files? And these are, more detailed explanations of what each one of these commands are. But can we generate a Docker file? Do we understand from workdir, copy, run, expose, and cmd? Great. So in that case, the only thing that's left is building the image, creating the image. And for that, the command is as simple as make sure you're in the same folder which has, your Docker file. And then here run docker build -t, which basically means what tag or what name you want to give to this specific image. For example, if I was the creator of Mongo, I would tag it with Mongo. But since this is our own application, you can write, whatever backend app or whatever name you want to give to this image. This name is important because whatever name you write here is eventually the name that reaches here. So if you try to use node as a name, you won't be able to push to Docker Hub because that's already taken by someone. So for now, add whatever name, doesn't matter. We're not pushing yet. And try to build the image. Docker build -t backend dot. You have to tell where to build the image from, which in our case is just the same folder. So just add dot at the end. No, sorry, still getting used to this application. There you go. Docker build -t backend dot created an image. Did what? It created this green thing on your local machine. Kirat, I did not have to pull it from Docker registry. Yes. You created your own image on your machine. You will push it to Docker Hub. You did not pull it from there because you created it yourself. Harkirat, the Mongo image that I pulled and this image that I just created by running this command, are they the same? Yes, they're the same. If you run Docker images, you will now see. Oh God. You will see the backend image and you will see the Mongo image, which basically tells you pretty much the same. This one you got from Docker Hub. This one you created locally. What's the next step? After you've created your image, what's the next step? Simply running it. So docker run -p 3000:3000 and then the name of your image, which I named it backend. So I'll run this, whatever you named it, just run this and you're good to go. Docker run -p 3000:3000. If you do this and go to localhost :3000, you will see your backend is now running on your machine inside a container. You've also added a port mapping so that any request that's coming on your host machine goes to port 3000 on the backend container. That's how you create an image for a Node.js application. Steps remain the same to create it for any type of application. And that's it for slide number 9. Yeah. And slide number 10 and slide number 11. So slide number 12 is what's next. Were you able to run it? Are we good to go? Do you have running a Docker image running locally on your machine? So basically, can you run a container? Is I guess my question. And the answer is, not a lot of yeses. It's okay. I think I took the results from the last one a little too hard and went a little fast. Anything specific that I missed? Any specific errors that you're seeing? Breather, recap. Okay, cool. Was slow ho gaya Mac. Okay, I guess the Docker build command was slow for a few people. So let me do a Docker PS and let me kill everything on my machine. Let me take you guys through the steps one more time. I have a Node.js application on my machine. And what did I add here? I added a Docker file. I added a Docker ignore. If I do a git status, it shows me, Harkirat, you have modified .docker ignore and Docker file. Ignored here, you've added these two files to your code base. So this is all I need to do to create a Docker file for my Node.js application. The next step is, how can I create an image from it? How can I tell Docker, okay, bhai, please go through step 1, step 2, step 3, step 4, step 5 and create this image? And the answer is docker build -t, which means give a tag to this specific, give a name to this image, which, the Mongo founders wrote Mongo here. You can write whatever, hkirat backend cool app. And then where is the Docker file? Where can Docker find the Docker file, which is in this folder itself? So dot over here. This is the command that might be taking some time for you guys. I guess I understand. Yeah, it did not take a long time for me because we'll discuss this tomorrow, but the answer is layers. So these steps happened for me really quickly. They might be taking a long time for you, which is why, a few people, like 50% were able to do it, 50% weren't. So just build is taking time. Feel free to let it take time. Once it finishes though, then, try to run the command again. And you will notice it happens immediately for you because Docker is really good at caching. And this is something we'll discuss tomorrow when we discuss volumes. But yeah, at high level, if you run this once, the first time it will take a lot of time because this npm install will take a lot of time. But eventually you'll see, this happens like this. All right. So I'll just wait for, another minute, but I'm hoping now it happened for most people. Let's do it. Let me just show the other command as well. Docker build followed by simply docker run and name of your application. And if you want to explore, then Docker images and make sure your image has been created, whatever name that you gave to your image. So See, now were you guys able to build and try to run it and see if it works? Still at a 70%. Let me open chat. Can you just, is it just taking time, or is there something else that's problematic? Time. Okay, we can wait. Why are we running database in a container? So when we close container, will data be erased? Yes. And this is where volumes come into the picture. But generally just use Docker for a database locally. Do not use Docker for a database, in production. Run it directly on your machine. Docker buildx command requires, if you see this error, you forgot to give the dot argument. So make sure you have dot at the very end. I'll just do this for 2 more minutes, guys, then we'll proceed. Just try to answer a few questions. Can we use Docker to route requests just like Nginx? Inside Docker, you can have Nginx running. Inside a container, you can have Nginx running that can route requests. Docker specifically is not used for routing. How can we give an environment variable to Docker container? That's exactly what we'll discuss next. Can we get a GUI for Ubuntu container in any way like SSH or something? You can. You can SSH into these containers. Can you get a GUI? Yes, you can get a GUI as well. I think, pretty sure you can get a GUI. You have to run X. I'm forgetting the name, but there's even for a remote machine that might be running, in AWS, you can get a GUI for an Ubuntu machine. Pretty sure. And same thing you can do when you're running it locally. But if not GUI, you can definitely get a SSH access. I'll show that by the end of this class. Taking time. Emulate Docker CLI using Podman. Create /etc resistant quiet message. No content. Podman related question. I will defer. Bhaiya, should we add a .env file to Docker container? That's a great question. So we'll get to that next. We'll be discussing environment variables next. It's a good question, whoever has it. And I'll give you a few practices to, where to store environment variables when you have Docker images. All right. So for the people for whom it's still building, I'm not running any more commands. Let me just share a few things around environment variables. So right now, if you look at it, our source/index.ts uses the Prisma client. And if you remember, there is a top level .env file, which I don't see because I probably removed it. Do you have .env.example? No. Okay. So there is if you remember when you used to run npx Prisma init to initialize Prisma, it would create a top level .env file for you. It would create a top level .env file inside which you would write, database URL equal to whatever was your database URL. This is how you stored your database URL. For example, let me quickly go to console.avian.io and get my database URL from here. Copy. And I've already migrated this database using this schema. So it will work for me. It will not work for you yet if you're trying it. So don't worry about it if it doesn't work for you right now. But this is how we stored the database URL using Prisma. If I run node index.js now and go to Postman, I can send the other request as well, the post request that will actually store some data in the database. It will not work for you because you've not yet migrated your database. We'll eventually get to doing all of this. Don't worry about it. I'm just giving a high level idea of where you store your secrets. This specific URL is something you should never share with anyone, right? You guys can see it right now. So you guys can clear my data, use my database, use my resources, I'll pay for them. So you should never commit this, which is why if you look at the GitHub for this specific week, you don't see a top level .env anywhere. I have not committed this specific secret. The question is, considering this never has this, secret, should the image have that secret? Should the container have that secret? How will our final application work when I start the container? How will it have the database URL to deal with it? That's a good question to ask. If I go to Postman right now, just to show you if this works, if I go here and send a post request to, / only, with a username and a password. It says socket hang up. I need to probably build. Would have hoped it would have worked without a build. Let's see. Validation error, database URL, environment variable not found, database URL, even though I have a top level.env. Can anyone quickly tell me what's up? Missing something obvious here. Database URL is present in .env, but I'm not able to see it. Double quotation. I don't think that should matter. Yeah, that's not it. DB URI not in string. No, it's not that. Container. Oh. No, I don't have a container running. I'm just running it locally. Node dist/index.js. Didn't say, so forget Docker file. I don't have a Docker file. I have a simple .env file where I'm running this. It's not quotes. It's not source error. Single quotes, someone said. I don't think they will change anything. Try Prisma migrate or generate. Oh, yes, that's it. Thank you, sir. Bounty $50. Sangram wins it. So I updated the .env. I did not regenerate the client. So, you know, whatever this client is, wherever this is coming from, it does not have my database URL. So I just need to run npx prisma generate. And there you go. When you run this, as you can see, it says environment variables loaded from .env. So it's getting my environment variables from there and then putting them here in the client. And that was the issue. Now, if I run npm run build and start it, you will see I can, you know, actually connect to the database. This request is taking time. It says done signing up. So this is how you would do it locally. But the question is, how do you do it in an image? There are a few ways. Number one, you can pass an environment variable like this, env, Docker, whatever, database. I'm unsure if this is the right syntax. If this is, you know, A equal to B, I think it is this. You can pass it over here. But what's the problem over here? Whenever I commit my Docker file, this secret reaches, you know, GitHub. I don't want GitHub to have this specific secret, which is why you don't usually want to hard code the database URL in the Docker file. In fact, you don't even want it on Docker Hub. If I have this, you know, image that I eventually deploy to hub.docker.com, I don't want anyone to come into that image, pull that image and see my secret. Your image should be secret independent. When you start the image is when you should inject an environment variable, which is why you will notice in slide number 12, I say Docker run, add the port mapping. And here I introduce the database URL environment variable and run the specific image because I don't want my image hard coded here. Can I do it? Yes, I can hard code my image, my secret in my image. And this is basically the question. Do you want your secret to be part of your image? It depends. If this specific image that you're pushing to Docker Hub is a private image, you probably can do it. You still shouldn't do it. You should pass your environment variable during execution. When you start the image is when you should inject the environment variable. So I'm going to remove this from here and then run the Docker image with the environment variable and it'll work. It'll not work for you. You don't have a database URL yet, but after the class, try it out. And yeah, this is the right way to inject a database URL into your image. I forgot what the name of my image was. So let me quickly show you that it works. Docker ps. So Docker run port mapping and then inject the environment variable over here. Do not have it in your image. If you start only the image without this injected environment variable, the post endpoint for sign up will not work. It does not have access to the environment variable. If I started with this environment variable and then go to Postman and try to hit it with a new username and password, you'll see it takes time. It says done signing up, which means this environment variable was injected to the final Node.js application. You might ask, Harkirat, if it was injected here, it means it was never run in this npx prisma generate. Then how did it work? It was not working on your machine a while back when you ran this command. And the answer is, if you inject an environment variable, then even if you did not have anything here, during execution, the Prisma client will sort of get the database URL from the environment variable. Just because I'm speaking a few things here, but let me know if you want me to repeat this. The thing that I'm saying is, okay, now I did not have the Docker URL, the database URL at all here. How did injecting it inside when running this specific command create the database connection? Because during client generation, we did not have the database URL, which is something, when we tried a few seconds ago, did not, never mind. I will explain this very well again from the top. But for now, the thing to learn is, this is how you inject environment variables. And this is how you start the application. This is the only extra thing that I've added. And this environment variable will be put where? It will be put in your EC2 container. It will be put wherever you're deploying your application, which is why, there's no secret leak anywhere. You don't have it here. You don't have it on Docker Hub. You don't have it in your GitHub code base. This secret exists nowhere. It exists only during execution when you actually start the Docker image. All right. Cool. Do we understand this, or was this a little dilly-dally? Do you understand environment variables and how you can inject them at runtime? By runtime, I mean, when you're starting a container. If you don't understand this, if you might remember from a few weeks ago when we were starting Postgres, then also we were injecting environment variables. But let me take a pause here and let's see what's left. More commands, fine. Pushing Docker, that's fine. So let's take a pause. Let me open chat, and then, after 15-20 minutes, I'll go through. We already know Docker kill. So this is just one extra command we can go through. And if we get time, we'll understand Docker Hub. We can do this tomorrow as well. But we'll see based on, how the ratio goes up. But right now it's like 70%. So any specific questions? Okay, I'm going to answer questions now. If you want to drop off, feel free to drop off. I'll answer questions for a while, and then I'll just take through one more command on slide 13, and then this slide 14 we'll do tomorrow. So feel free to drop off. It's a simple command. You can look at the recording. So you can basically call the class here. I'm going to answer questions now, and fire away. Can we make container inside a container? Yeah, there's a whole project called Docker inside Docker, DIND. Not recommended. Pretty anti of a pattern, but apparently you can do it. Shouldn't do it though. Like, I've gone down this rabbit hole only to realize there's something you shouldn't do. Docker database versus cloud database. Cloud database. How Prisma get access to environment at runtime? हाँ ठीक है, चलो ये question कर लेते हैं answer. This is a very good question. Let me share a few examples of the thing that I was talking about that I thought let me explain in a while. The thing was, okay, Harkirat, let's say during how do I stop this? So forget Docker for once. There is no Docker. There is a simple .en Node.js project. Forget this Docker ignore exists. Forget this Docker file exists. There is a simple .env where you have your database URL. And when you are generating your client, you run npx prisma generate with this over here. When you ran npx prisma generate with this over here, then your Prisma client will, as you can see, it says environment variables loaded from here. It will understand, it will have access to your database URL. But let's say I make this empty. If I make this empty and do a npx prisma generate one more time, Now my client doesn't know what the database URL is. It's not present anywhere in my source code, which is why now if I run node index.js, npm run build followed by node dist/index.js, you will see if I send a request, it's pretty much, breaks. It says cannot find URL, database URL. But if I do this, database underscore URL equal to something. So I'm not putting it in .env. .env is still empty. But if I do this, this is a way to inject an environment variable inside a Node.js application. If I inject an environment variable while starting a Node.js application and send this command, you will see it works. Did not work. Did not work. Let's see. Let me try one more thing. Maybe I'm not. Most probably I'm not. Let's try to set. So there's another way to set an environment variable. Let's see if that works. Export database URL equal to this thing, and then run node dist/index.js. Send, and did not work again. Let me try one last thing. Start. I'm sure someone in the chat knows the answer. I can see a few people popping up, but let me quickly try and then I'll open chat. If I run this, npm run start database URL, that looks right. Still not work. Okay, now, so let's just see first, do we get console.log process.env.database URL? Let's try to log if we are able to get, we are able to get a database URL. If we start, it does not work. But then how did it work in the Docker file? Because in the Docker file also, when we were generating the client, we did not have access to the URL. But when we were running it, oh, it didn't work here as well. Now, could have sworn this worked the last time we did it. Database URL. What did I do? Did I mess something up? Let's see. This did work the last time, right? Let me open chat. Okay, sorry, ad hoc, slightly ad hocish of a class. Let's see. A few people are saying something. Prisma migrate. No, I get it. Missed and. Email error. Can we get variable at the top of the .env file? Docker compose file. Sure about the Docker file. Email field. Production. Don't think that's it. Oh, fucking A. Yes. Thank you, sir. Unique constraint. Saurabh Padman. Sorry, Padman. What? I apologize. Saurabh wins the bounty. And the thing why it was, the reason it was running and it's not running right now is because of a unique constraint. $50 bounty, sir. Thank you. It's because I'm sending the same email again. And that email already exists in the database. Now it does work. So now trying this one more time. Let me stop the Docker container. Docker ps. Docker kill. And now what I was saying was, even though my .env file is empty, if I start, there you go. If I start node index.js, and while I'm starting it, I inject this variable, it will still work. As you can see, the variable got logged, which means, process.env.database URL exists. So basically what's happening in this Prisma client somewhere is, it basically gets, my process.env.database URL or the default URL, which we did not give it a default URL. But since we injected an environment variable, it worked. And now if I go to Postman and send it, it does work. I was just, sending an email that already exists, which is why it was throwing basically this error. The same email cannot exist twice in the database because we have a unique constraint over here. All right. Thank you, sir. Saurabh, kudos to you, sir. Good one. All right. Now I'm going to open chat. Firstly, how are we doing? Did we understand this part? I went a little quickly. So I can summarize this part again. But do we understand this? Are we good to go? Or should I summarize? Are we good to go? Yes or no? All right, good to go. Pretty good. Cool. So in that case, the next thing then quickly that we should learn / is good to know is this thing right here on slide 13, which is some more commands. Specifically Docker kill we understand. So Docker exec. This is a common command to execute a command inside your container. You have started a container, but let's say you want to see the contents of a file there. Let's say you want to SSH into that container and get shell access. For that, you can use Docker exec. So if I start another container, Docker run, doesn't matter what. Let me start a Docker container. And now let me go to another terminal where first I run Docker PS to see all the containers that I'm running. I'm running this one. If I want to see the file system inside this specific, container, if I want to literally explore the container and, get bash access to it, then I can run Docker exec. Now, if you want complete access to it, you have to run it in interactive mode, which basically means, you're not running a single command. You want to perpetually open this container. Then the ID of the container, which you can get from here, space /bin/bash. Basically means run this command in this container interactively. And now, as you can see, I am in the /app folder. I'm in the working directory. If I press ls here, I see my node modules. I see package log.json. I see dist. I see Prisma. I see source. This is all of those files inside my mini container. If I run top, I can see, the CPU usage. If I run, pwd, I can see I'm here. If I want, I can explore this container a little bit more. And whenever I'm done, I can exit out of it and I can reach back my Mac machine. So this is my Mac machine. If I run Docker exec -it, the ID of the container and then /bin/bash, this is my actual container, the file system of the container. If I want, I can kill the process that's running on 3000 and my container would die. So, you can do notorious things, but if you want, you can just, explore your code base, do things like these. So yeah, Docker exec lets you run commands. You can run them interactively, or you can simply be like, hey, bro, I don't want to run them interactively. Docker exec on this container ls. Then what will it do? It will just run ls in this container and return you and exit out. You're not running it interactively. If you want to run it interactively, then -it. Cool. Hoping that's pretty straightforward. That's pretty much it. That's a decent chunk of Docker. The good thing to learn, or the big thing to learn here is creating your own Docker containers for your application. So if you look at, the contribution that person made, let's see. If you look at the pull request for whoever added, this guy added Docker ignore, but there's another. So this is also a good contribution, right? Someone added Docker ignore, but there's, I think the same person only added Docker file as well. Let's see. There you go. So this person added a Docker file, updated the README, added something called Docker Compose, which we'll discuss tomorrow. But if you look at the Docker file, it's pretty similar, right? From node 20 Alpine, working directory, they selected /source/user/source/app, doesn't matter. There's something different they did. They copied these separately for some reason and then ran npm install and then copied the rest. They could have just, have a single copy over here, but they selectively copied a few things, ran npm install, and then copied everything else. We'll see why they did that tomorrow. And then expose 3000 npm run dev::docker, which is some script that, they introduced over here, which, as you can see, injects a database URL and then does Prisma migrate deploy and next dev. This next dev is what starts the application. So this is the contribution that this person made. I think there was a bounty. I could be wrong. That's what probably was. I don't know. if there wasn't, there should be a bounty to this. It's like pretty obvious bounty to win. And they updated the README. They had Docker Compose, which I'll share what this is tomorrow. This just seems like they cleaned up the schema a bit, changed the log file. That's it. So yeah, this is hopefully something you can understand and do now. And the only thing that's left now for at least today for the simple stuff was pushing to Docker Hub, which you can follow these steps. It's very simple. Just Google it if you want, but just sign up to Docker Hub. Create a new repository over there, similar to how you create a repository on GitHub. And then, do a Docker login to actually log in to Docker CLI, and then simply run Docker push. The only thing that's weird here is, you have to make sure you name it a certain way. For example, if you have, 100x devs username, then whenever you create a repository, that will be 100x devs / that repository name. So make sure you're tagging your image correctly with that specific name, 100x devs / your repo name. And whenever you're pushing, you're doing the same thing. That's really it. We'll cover this tomorrow as well, but feel free to take it as an assignment and try it out. With that, that's all for today. To quickly recap, what have we done? We understood the whys of Dockers. We understood what is containerization, history of Docker, the founder of Docker, things like these, how to install Docker on your machine. Inside Docker, this was containers, images. The other thing we learned here, totally forgot. I remember the diagram a bit. Yeah. Docker engine, CLI, things like these. Then we understood containers versus images, port mapping, common Docker commands, Docker run, Docker build, what is a Docker file, creating a Docker file for a Node.js application, building the image, running the image, passing in environment variables, and then some more commands like Docker kill, Docker exec. Tomorrow we'll understand pushing to Docker Hub. If you want to know more, we'll tomorrow understand volumes. We'll understand networks. We'll understand layers. If you understand layers, networks, volumes, and pushing to Docker Hub tomorrow, that's great. That's more than enough for what you need for most use cases, at least for a long time. With that, open for questions, guys. All right, start from the top. All the images have base Alpine versions. No, so Node, Golang, all of these will have a base version and Alpine version, which is like, so depends. So Node.js, if you select the base image as Node, if you look at oh, sorry, put this on the side. Okay, something is up here. Okay, 1 second, guys. Something has broken. Okay. What I was saying was, if you look at Docker images, you'll notice this has a size of what? 1.29 GB, because this brought a very fat image on my machine. The Alpine versions are slimmer. If you install if your base image was Alpine, Node Alpine, then you'll see like 200 MB over here. So depends on who has created that image or not. It's not necessary every Golang, Node.js, every language has its own Alpine version. Most of them do, I'm assuming though. Always have to use for using always a good idea to use smaller images. Do we have to kill container every time we change project? Not necessarily. Your container can run perpetually. If you want to run something else on the same port, then yes, then you need to kill the container. Docker images में change करने के बाद, can we change the image? You can change the image. You can regenerate the image. You can re-push the image. In fact, every image has multiple versions. If you go to hub.docker.com/Mongo, you'll see Mongo has multiple versions. So as you update your images, you give them new tags and push them. This is 5, this is 5.0, this is 5.4 local, 5, so on and so forth. So there are multiple versions to every image. You can keep regenerating them, and as you regenerate them, you will create new versions and push them. But I don't think GSOC organization is worth his time. I'm confident getting selected in an org, but I don't want to work because the technology is outdated. Yeah, if money doesn't matter to you. So back then there was a lot of money for me, so I would still do it. But if money doesn't matter to you, I don't know how much they pay right now. I think they still pay a lot. That's fine. That is true. If it's a very outdated technology, but the good thing you'll get is remote work experience. Why miss it, Kushagra? I would still do it. You can do a half-hearted job, but I don't think it's the worst idea too. If you're saying you're getting it, I would still take it. But that's just my opinion. Docker images. What I'm confused about is Docker images like a snapshot of the code. It is a snapshot of not just the code, but the file system. It is a snapshot of what everything looks like after all of these things are done. It's not just a snapshot of the code. It is a snapshot of another snapshot which has Node.js plus a bunch of your code and then a snapshot. What I'm getting a bit confused is okay, answer that. Code or image updates, the code changes and then you have to build image again and push it like push on GitHub. So anytime the code changes, you will recreate the image, you will push a fresh image to Docker Hub. We will do this eventually. We add a CI/CD pipeline, and what will happen in that pipeline is anytime you push to GitHub, anytime a commit happens, a new image is generated, and that new image goes from GitHub to Docker Hub. So we'll get. I know this was very easy to understand, but we did this in the last cohort, which is why we'll probably do this here as well. Okay, we'll write a CI/CD pipeline so that whenever on GitHub a new commit happens, there is a pipeline that runs here that pushes this new code over to Docker Hub, and then if we get the time, we'll also in the same pipeline write. Okay, once this has reached Docker Hub, go to AWS and pull the latest image from Docker Hub and rerun it. We did this in the last cohort. Might do in this cohort as well. That was what we did in CI/CD last time. But yeah, every time there's a new commit, a new image is created, and then you pull it again. Harkiyat, every time there's a new commit, a new image is created. Yes. Isn't there a lot of space? Yes. So you add like expiries. Okay, after 3 months, all images get deleted. Or you have only 100 images at a time. But it's not too expensive to keep pushing images on every commit. Version control may manage hota hai. Code changes are happening in Docker. In Git, Docker images is also getting updated. How? So yeah, as I said, every time there's a code change that gets pushed to GitHub, we will eventually add a CI/CD pipeline that will push that change over to Docker Hub, and then go to the AWS machine and pull that new image over there and rerun that image. Why /bin/bash inside container? Because /bin/bash starts that bash session for you on that container. Basically means I want to start a bash session in this specific container. Does Docker have its own network, like a private subnet in AWS? No, not exactly. Your Docker container has its own network, as in it will have its own private IP, but it does not have its own network on AWS. You have your host machine, your host virtual machine, wherever you're running it, and it's just the network of that machine. Use case, if I run one container front end, one container back end, and don't want the backend to be exposed, then you just don't add the port mapping for the backend, right? If you don't want the backend to be exposed, you start the front end like this: Docker and -p, whatever your port mapping is. Front end, whenever you start the backend, you don't add any port mapping, so no one will be able to reach that backend container. Honest inputs, please consider once. A core Notion doc. Sir, 0 to 1, can I get a 1 to 100? Just ping Rookie, he'll help you out. I need to make a project for internship application. Can you suggest a good one which solves the problem using stack, TypeScript, etc.? So here the project doesn't matter. I mean, probably so make something close to the company, but more than that, use the most modern syntax. Make them very make them very super impressed. This code base is even cleaner than ours. Add a CI/CD pipeline that pushes to AWS or whatever their cloud provider is. Show them this extra bit of things that you can do, so that they're like, oh, this is a person. I mean, don't do a little too much. If it's a big company, the employee might get intimidated. Oh, bhai, isko itna aata hai, he'll come and take my job. But if you're talking directly to the CEO, over impress. Add a CI/CD pipeline. What matters is how clean your code is, what technologies you're using. Project does not matter, but if I had to pick a project, I'd pick a project close to what that company does. Currently, I'm going through week 2, and week 15 classes are very big to me. I guess, you'll have to finish that's correct. Another Notion doc. I want to use S3 client on the Medium clone for posting images. Is it necessary to use connection pooling for that too? No. S3 client, if you're uploading images in the Medium clone, search for something called pre-signed URLs, so that your browser directly sends an image to AWS and it doesn't go through your middle server. And in that case, you don't have to worry about connection pooling. If you do send it from your backend. I think it's fine. You don't need to. I don't know if there's a concept of connection pooling basically. And anyways, it doesn't. So S3 initiates a new connection anytime you're sending an image or a video from a server, which is why it doesn't matter. I think in your case, you probably don't need. I don't think there's a concept of connection pooling in S3 clients. Not found. After I run this, yeah. So npm run dev is not found. That what does that tell you? It tells you okay, your package.json doesn't have a dev script over here. So add a dev script in package.json that does whatever node index.js or whatever node dist/index.js. Let's see. Let me start from the bottom. Does Docker have its own network? Like, so that please version advanced git commands. Sure, like rebase and stuff. Okay. Way down the line, there are like a lot of things on the stack to complete. We have to complete a lot of Next.js stuff, but eventually, sure. Docker and this thing -e this thing that looks right. So image name, Vijay, make sure you're replacing it with your own image name. My company works on payment devices and we have to deploy many devices in different locations. And can we create an image every time of the entire OS and all the software there? Can Docker be an alternative? And we create an image every time of the entire, yeah, exactly. So yes, Docker can be an alternative there. Even better is what you can do is, so your use case sounds pretty straightforward, right? You have an application that needs to be deployed in various locations. And one location might have AWS servers, one location might have GCP servers, one location might have your own native machine, you might own a data center. So in these cases is where Kubernetes is actually much more, call it, useful than Docker. You still use Docker. You probably still use Docker at the very least. So what you'll do is in every machine of yours, you'll just start Docker, the Docker runtime, and then you can just run that image. But eventually you'll see a lot of power. Like this is exactly what Kubernetes solves. If you have various cloud environments where you have, multiple machines all around the world that are not on AWS, let's say, it lets you very easily orchestrate, code on various machines. So I'd look into that. If I was you, but to start off, Docker is great. Explain Docker file syntax one more time. The good thing is it's not too many lines of code. It's 13 lines of code. It says कौन सी base image है, where what should be the starter image, which means another image from Docker Hub from where we build the rest of the image. Starter image is Node.js, a basic Ubuntu machine which has Node.js installed. Then it says working directory kya hai, what is the place where you want to copy the code and run these commands. And we say /app. Can you name it /Harkirat? Yes, depends on you. /app /user local /app. These are like common places where you store your application. Copy over the source code from here dot into the container. Can I do this, Harkirat? Copy package.json over to dot, and then copy package -lock.json to dot, and then copy source to dot, so on and so forth. Yes. If you don't want to copy everything, you can go line by line. The goal is you copy all the contents of the project over to the container image, then run npm install, npm run build, npx generate. Tell what ports the container should expose, and then finally a command that runs eventually, that runs when you actually start the container. These run when you create the image. That's a high level. Can we delete .env then? Yeah, you can delete it. You usually have it for local development. So usually what you have is actually .env.example, which is something you commit to, GitHub as well. You have a database URL equal to your DB here. This is what you usually have. And whenever a new developer clones your project, they get this .env.example, copy the contents from here, paste it over here, and then replace this with their own database URLs. That's how local development works. And for prod development, yes, you don't need .env. You could just inject the environment variables. Why didn't you start CMD node index.js in one go? Why separately? Oh, so this is like common syntax when you're starting. So when you do node index.js, you're actually running node, the command, and giving it various arguments. Index.js is the first argument. Whenever you're running docker run exec -it /bin, whatever you're running, this is the command that you're running. these are the arguments that you're giving to it, which is why not just here, in various places you will see, okay, you're giving us an array of commands rather than, writing node disk/index.js, because you're not running node index. This is not the command you're running. You're running node and you're giving this as the first argument. Can you give more arguments? Maybe if your application wants, ours does not. That's a high level of, why you'll always see, even when you're using something like either spawn or exec, I forget which one, probably exec in Node.js, you'll see, you first pass in node and then you pass in a bunch of, array of arguments. So yeah, that's why. Cool. Yeah, I'm a little busy right now. What CMS PRs have I not reviewed? I thought I try to clean it okay. I'll get to it. Thanks for the reminder. This week was a little busy. Can we go through CMS codebase? One more thing. Wait for another. So we have a few things left in Next.js, specifically middlewares, client-side rendering, server-side rendering, and Next.auth. There'll be offline videos on them. 99% next week. After that you can go through it. Cool. Let me go through all the Notion docs. Very long recoil doc. Let me come to it. Let me look at the smaller answers. This one isn't open. Check Docker version, check Docker container running, remove a Docker, check a Docker, create a new Docker container, to pull an image manually, to start an existing container, to stop a running container, to execute a command running, to get out of a command. I didn't know this. Nice. To expose a container on multiple environment variables. Fucking beautiful. So $50 bounty, sir. I'm going to yoink your thingy, and feel free to just take $50 from Rookie. Yeah, I'm just going to copy this over to to this week's whatever. Oh, it's the wrong one. Never mind. I'll copy it. I hopefully I don't forget. But yeah, thank you. Sorry, where did the recall one go? Feedback. Refresh this page while counter questioning. I am updating it live. Okay. Please extend this thing. This is happening, probably a little bit more than this, but yes, this is happening. March end at the very least. Challenging topics to cover. We'll cover how to integrate verification, email. Probably can get it covered from someone. Fairly simple. If it's fairly simple. If I don't do it, someone else. I'll get someone else to do it. MVC, sure. Little dilly about this one. Because MVC next, very low down the priority line. Sure, this will probably come very well during the OpenAPI spec. How auth into React application. So React application cannot use Next.auth, but I'm assuming you're saying tokens on the client side, how to proceed protected routes. So React, right? We can do React auth. We've already done React auth. You probably want cookies and a bunch of things that I did not assume that was simple. This will definitely come. TAs are good, but AMA session with you are the best. So I request you to start at least one AMA session per week on Wednesdays. On weekdays, I will not commit this because time commitments, but we'll see. This is let me do a quick poll. Thank you for a smaller lot here. And honestly tell, are TAs responsive? Yes and no. Class if not, that's not the case. And the second question will be, what do you prefer, TAs or personal work? So 66%, which is good, not great. But not as bad. I scream on them, but okay. What is better? So I have a few options here. Discourse, like I'm sure you guys don't know what Discourse is, but it's pretty good. Discourse, not Discord. If you don't know what Discourse is, it's like Reddit, a subreddit where people can post doubts and you can answer them. TAs, Discord, doubt sessions, and then lastly, Harkirat live session. This is a very skewed sort of a question. Of course, you guys will select Harkirat live session. Shouldn't have asked this question. Okay, cool. This is great, by the way. Thank you for this. Bookmark it so I don't forget. A lot of these topics are in my head, just not getting the time to get to them. And Extension, don't worry about it. March end, April mid, April end, doesn't matter. As long as 0 to 1 people are getting value and it's not getting very high level, you guys can stay. Okay. There was a recoil question. Can you please help me? I have a single API and I have two different atoms. For example, one atom to store an array and another to store an object. How can I set data in both the atoms using single selector? Is it possible? No. You can never set data on a selector. You can give it a default value. You cannot update data on a selector. It's called selector for a reason, right? Can you please tell us this is the correct way to do it? If no, how to achieve it? So you need to achieve it via atoms. You can't update data on a selector. You can give it a default value, or how to fetch that selector's data from other. Yeah. Set data, use set recoil state atom A, atom B. These two look right. Use recoil value. So, okay. Why are you doing all of this inside a selector? This is just hitting an API endpoint, right? And getting the data. Why not do it, either direct? It does not make sense for this to be a selector. This needs to be a selector if the data inside is reactive. If this data depends on another atom or depends on another selector, then it makes sense to create a selector. This is just standard data. This is just an HTTP. You cannot write return 1 from here. I mean, you can, but no need for it to be a selector, right? You store things in selector which are reactive, which if this thing depends on something that changes. If this was a hook, which it isn't, it's a simple fetch call. But if this was a hook is when it would have made sense. So yeah, basically you do this inside a function and then go from there. This data A, data B come from a function, which basically means you might have to do this inside an effect and then set the data. But yeah, that's a high level. Hopefully that answers your question. Going to open chat one more time, guys, and then we will call it. How many? By the way, excited to see you guys in Bangalore. We're doing a few things. At least I'm trying to do a few things. I don't know what will happen. Like, a lot of people are coming. Etsing is coming. All the stand people will be there. Someone from Solana is coming. I'm trying to make it a little theoretical. It's a big venue as well. I'm contributing to one of the orgs. You shared from the previous cohort. There was another guy that came in that org and now made very good contributions. And within a week, he got the GitHub sponsor from the founder. And I'm sure he would get the remote job. I'm sure too. Now I stopped contributing there. Should I figure out a new org? So if it's a GSOC org, right? No, it's not a GSOC org. I mean, you can still get there, like in the same company, but it's not a zero-sum game usually. If someone's contributing doesn't mean you cannot contribute. That said, if someone's this good, yes, they're going to fill him in first. So pick and choose, dude. Yeah, this is probably part of life. And timing. He came. If you would have probably stayed for a week and they would have offered an interview, that did not happen. Now it most probably won't happen. So, or he'll get first priority. So yeah, I depending on how much people they need now, I would either move or stay. 3 questions, I think I answered them. Let's see. How to find good repos for contributing? Just find what interests you. I don't point to repos anymore because they get spammed. But you can do 2 things. One, find a repo that's very good code that's written. So a lot of websites are open source. I can say one name because I've said it many times and the contributor there is very nice. dub.sh. But other than that, it's do it for the skills. Don't do it for a job. Job will be an eventual outcome. Yeah. Is what I say now to avoid any spam. Why not use Docker in production for databases? Yeah, so few reasons. One, so it's not like you don't. You do. Sometimes you do as well. It's just generally a little scary to own database deployments. Because if data gets lost, you're screwed. So it's usually something you defer to cloud providers. By you use RDS from AWS, or you use whatever NeonDB, AVN. Databases is something you don't usually own unless you have really sensitive data that you don't want shared anywhere. So that's one. But generally when you're starting it, why running it inside a Docker container is a little scary is because of a little bit because of persistence. You can add persistence to Docker. By persistence, I mean if a container goes down, the data gets lost. You can get rid of that. When you're using Docker, I've seen people, in fact, one of my previous companies, the database was owned in-house and ran not using Docker, but using Kubernetes, which is running Docker under the hood. And in Kubernetes, there's a concept of something called persistent volumes, which pretty much lets you do the same thing. It lets you create, as the name suggests, a persistent volume where data remains always. So you do it, but generally, unless you have a very data sensitive application, just defer the database, outsource it to a provider. How can we trust if a Docker file on the registry is not corrupted? You cannot. Can you trust a software that you're downloading on your machine? No, right? You can't read the code base. Similarly, you can't trust a Docker image. What if Ubuntu image itself gets corrupted? It won't subsequently. Yes, that is true. What if the Express npm library gets corrupted? Everyone that uses it gets corrupted, right? So a little bit of trust there. People are not putting corrupted code, but yeah. How often, and also these are audited from that. There might be a certain version that gets audited, which is why it's usually a good idea to, whenever you are using Docker containers locally, you download a certain version or what's called hash of a certain version that's been audited by someone. So at least this hash is not corrupted. A future one might be, but this specific tag is not corrupted. It's been audited. For a lot of times, whenever you have a security review in your company, the first thing they will tell you, I know this because I did this, and then the security review company came back with this and said, tag this to a certain version, and the version needs to be some version that's been audited, so it's a clean version. How to find? Okay, so there. So you're a feature for Django developers. Yeah, it's most of the, not most, but a lot of GSOC organizations this year are Django and Python. So at the very least, I'd look there. But I know a lot of companies. The Web3 company that I referred a few people to, they use Django. That's their primary stack. They're in Bangalore on site. Amit, if you want to get referred, let me know. But they're very smart people. So I don't know. Make sure you're very good at Django, and then they have their own stack is Django. I'm happy to refer you, but that's on site in Bangalore. I'm trying to build and grow an application that got some errors, like crypto does not want. Exactly. Crypto does not work. And the crypto library does not work on the edge especially if you're using it on Cloudflare workers. But let me read your question. It's really confusing with all the sessions and stuff. What are the things that I have to use to do all the stock graphs, get the stock data in real time? I found Upstocks has some APIs, but I haven't really digged deep into it. So you want to create a crypto native. Okay, I don't understand what you mean when you say crypto here. Is it a crypto library or is it cryptocurrencies? But if you want to get crypto data, CoinGecko has an API. If you want to get some other data, there are a bunch of, as you said, Upstocks, bunch of similar API providers that let you get the current price of stock, which I'm assuming is what you need. 3 questions here. Oh, why is it not opening? Medium application. Well, right off the bat, it's a little, what's up here? Why is it you see the issue? It's, this isn't great, my friend. Not something I would tout on a chat over here. Just fix the layout. So this is exactly what I built, and it's an uglier version of it. So, make something better, and then I'll be happy. But it's good. It's a good start, but again, a lot of things to do before you can, say it's really good. How do you know the current app is running on a Mac port or running on a mapping from a Docker, and why are you using npm build if it's already there in the Docker file? So how do you know something is running on the Mac machine or the Docker machine? The Docker container is. So there are a few things that are happening, right? You're telling Docker, okay, I'm going to expose something here. You're running this thing, which is actually starting something on the port 3000 here. And then you're giving a port mapping here. Okay, bhai, something on Mac 3000, please, any request that comes here, please go here. And lastly, you can, always run commands on your Mac machine to check what is running on a certain port. For example, if you run ls-f3000, basically lets me nothing is running. If I something should be running here. Maybe I'm just not able to read the output here, but you get the idea. There's like very easy way to find out what if something is running on your Mac machine, and whether or not something is running on the container depends on your application logic and what you're starting over here. Let's go to the bottom. Fail to read Docker file open down. Your answer is right there, right? It says Docker file doesn't exist, which means you're either not in the right folder or you have named the file incorrectly. You have not named it Docker file. So just fix that. But can you explain drawing how Docker and Docker under Ubuntu and Ubuntu के अंदर ऐप एंड डिपेंडेंसी कैसे काम करता है? भाई कैन यू एक्सप्लेन डॉकर एंड डॉकर के अंदर उबुंटू एंड उबुंटू के अंदर ऐप? ओके या सो my Mac machine, I can start an Ubuntu container here, which means I can start a mini machine that is running Ubuntu. Harkirat, how? I can just go here. I can say, bro, base image needs to be Ubuntu, whatever latest version. I just need to make sure, something keeps running always. Otherwise, it will start and the container will stop. But if I'm able to, run a command that's perpetually running, then I just need to run this specific container. And then I'll have a mini Ubuntu machine running. If you remember, I showed you a command, docker exec, that lets you go inside this mini machine as well, SSH into it or get shell access basically. And then you can run multiple commands inside that container. So this is your Mac machine, inside which you have an Ubuntu container. Harkirat, is this Ubuntu container inside some Docker thingy? No. Docker is just the thing that lets you create these containers. Whenever I run a command, by Docker start something, Docker will be like, okay, I am going to start a container. And then that's what's starting over here. That's a brief of, Mac inside Ubuntu. Someone asked, can you start Docker inside Ubuntu? Can I create a small Docker instance inside which I can have another container? And the answer is, from a few years ago, when I've had the same question, I had reached something called Docker inside Docker, DIND. Running Docker inside Docker, yeah. So there is a way to do it, but it's a very weird, pattern. You probably shouldn't do it. In some use cases, it feels like this is something you should do, but almost always, you can find another way to do it. Okay. How can we answer that? Bro, authentication सिखा दो. JWT token store करते हैं cookies में, वो सब. So we've done authentication using, authorization सिखा दो. So there's a little difference. Okay. There will be a video on authorization, authentication, cookies. I guess these are the three things that a lot of people want to learn. This was part of that doc also that person posted, so I will do it. How is Docker useful when we are hosting our applications to AWS? It's not useful if you host it on an EC2 machine, but eventually we will see, this is GitHub. From GitHub, you push, anytime there's a commit, you push your new image to Docker Hub. And then once you've pushed this image to Docker Hub, you will see a few things, which, mostly is, usually a Kubernetes cluster or something called ECS inside Amazon that will pull this latest image and start it automatically. So we'll see how this happens later on. But, the idea is if you are running it on a single EC2 machine, like we've done until now, like we've done deployment until now, probably don't need Docker. But eventually when you want to auto scale, auto deploy Docker images on a Kubernetes container is when you'll see, when it becomes useful when hosting applications. What does the VM on AWS run the Docker file or the entire project we do locally? It runs the Docker file. Right now, so the way we've done deployment until now, it runs it directly on the VM. You can start it inside a Docker container on a virtual machine. Is Docker file only useful when we are cloning and running someone else's application or machine? No, it is also useful when you want to deploy from GitHub to Docker Hub. If you want to create an image on GitHub Actions and then, push it to Docker Hub. So if you have an action that will, anytime there's a commit on GitHub, it will start a small Ubuntu machine, run your Docker file here, generate your image here, and then push it to Docker Hub. So it's useful there as well. Whenever you want to create an image, doesn't matter where you want to create it, locally or somewhere else, you use Docker files. How is env variable passed for the Docker file when we deploy it? That's what I said. It is never present, or it usually shouldn't be present in the image that's present here. You should not have any secrets in this image. Whenever this image starts over here, whenever you're starting a container, is when you should inject the environment variable. Next auth we will cover, and Docker hosting on AWS can cover. It's just, sure. It's just going to be me starting Docker on an Ubuntu machine and just running the Docker run command. So if that's what you want me to do, happy to do it. But eventually we'll see, how you actually deploy containers and do container orchestration. I'm currently, okay, that's a slightly off topic of a question, so I'm going to ignore for now. Why we should build lead code and replicate an isolated environment? Oh, I have a video on this where we hacked I got hacked Harkirat Singh. Just go through this video. It basically explains what you're asking. Biggest mistake website developers make in 2023. The other question. Oh, sorry, it was in the doc. Should we always build containers? For example, to-do application? No, depends. Depends on your company as in where the company that you're working at, the scale that you're going to hit. Do you need auto scaling? Do you need aggressive auto scaling? Do you have a lead code like application? You don't have to. A lot of people don't. A lot of companies work without containers, without Kubernetes. This is the fanciest thing to pursue. If you has some benefits, you don't really need it though, unless you have a lot of scale, you have a lot of orchestration that's needed. When to use Docker? Initializing project, in the end while deploying. Please try to restart your screen sharing, face not visible in full screen. Last time it worked. Okay, got it. Makes sense. Add this to your shelf. What is that? Let's see. Clean architecture in React. The one. Okay, we need third. Alrighty. Any more questions, guys? Can we configure a base image according to our needs organization? You can. You can have a organization specific base image that you deploy, and then all your organization. Yeah, you can do that. Yeah, I was the one who implemented Docker file for CMS. Been following you since January. Thank you for everything. Oh, thank you, sir. I appreciate you. What if you have multiple environment variables? You can just pass -e multiple times. The command will not necessarily long. It will, which is why you can write. So eventually, when you reach container orchestration, you'll see the way you pass environment variables is something else. No one goes to an AWS container and starts Docker runs a Docker run command. You use Docker for deployment when you use some sort of container orchestration, and there the way to pass environment variables is something else. It's not passing -e. What do you want to? So yeah, if you want to add multiple environment variables, add the -e command multiple times. I think that works. I could be wrong. Let's see. Docker run. Yeah, you can just pass. If I'm not wrong, I could be wrong, but I think you can pass -e that equal to something, and then keep doing that. This failed for a different reason. I think you can do this. If not, Google it. I'm sure there's an answer out there. You can pass multiple environment variables. Yes, I am using rectangle list shell. Thank you. I also used it in my GSOC video where I was being like, oh, I have a fancy setup. I have a keyboard only setup. But there are two things I recently learned, which was rectangle. I think thanks to you or someone else. I don't remember who suggested it. And Vimium, which is another thing I used. So yeah, appreciate it. But I have $200 on DigitalOcean credit for 2 years. And Heroku, should I use them? You can use them. Yeah, you don't have to go with AWS for these KDE applications. All right, guys, let's call it. Instead of pulling Docker images to AWS machine, can't we directly on Docker? No, you need to pull it on the machine. You need to have the image somewhere, right? So you can't, skip putting it on the AWS machine. Let's call it here, guys. I will see you guys tomorrow when we do. Also try rap.dev. Little finicky about that one. I'll see. Terminals are something I don't want to, give a startup an access, but we'll see. All right, guys. Thank you. I will see you guys tomorrow. Bye bye.